Hello everyone, I'm Kiran Sirupa, Director of Marketing with Anuta Networks. Today I'm supported by my colleague Dilip Krishna. Hi Dilip, can you say hi to the team?
Hey everyone, Dilip here.
And we also have Praveen Vangalam, who will be our expert commentator. He will answer most of the questions as well. Praveen?
Hi everyone.
So let's get started. We have a very packed agenda, as Ethan mentioned. What we will do is we will provide an introduction to Anuta Networks. As you may not be so familiar with our product, we will discuss some of the features of Anuta Atom product, and then we'll go into some case studies, things where customers have seen the ROI, and then Dilip will walk you through the demo. The presentation should take roughly 20 minutes, but feel free to ask your questions. You can submit in the Q&A panel, and Ethan and Drew will pick up the relevant questions. So let's get started. So we all know the networking is complex, and it's getting very complex with trends such as 5G, IoT, and edge computing. Networking is going to be even more critical. But when you look at the network automation landscape, the operators have a daunting challenge. They have to have expertise in config management, compliance enforcement, software upgrades. They need to have expertise on designing the policy and troubleshooting. And all the while, they have a lot of constraints. They have to reduce the OpEx. They have to deal with multi-vendor infrastructure. There's a lot of brownfield deployment, and there are a lot of existing scripts that need the care and feeding. And not to forget, there is a trend towards hybrid multi-cloud. So the management is always looking at standardization and automation. When you look at the tools that are available, as you can see, there are many tools. There are tools for documentation, there are tools for provisioning, there are tools for analytics, and there are tools for remediation. But what is happening is your information is stuck in islands of databases, and there is no cohesive way to look at the entire infrastructure as one unit. There is an urgent need to have a comprehensive solution that delivers documentation, provisioning, analytics, and of course, troubleshooting. So let me introduce you, Anuta Atom. Anuta Atom is a comprehensive network automation solution. It is a software-only solution, but it works with multi-vendor infrastructure. It helps all the way from onboarding the new devices, configuring the various day zero policies on those devices. It helps with software image upgrades, and it introduces a self-service capability. So from a simple GUI, you can push configurations to hundreds of devices. It also collects analytics using either streaming telemetry or the traditional SNMP. And using the concept of closed loop automation, it helps achieve the compliance with your infrastructure. We will go into more details of each and every feature of the Atom that we highlight here.
So quick question, Kieran. You mentioned closed loop automation, and you've got it on this slide here as well. Does that mean intent-based networking? Sometimes those two terms go hand in hand.
Yes, intent-based is probably a superset of the closed-loop automation. What we are doing is we are identifying the day-to-day operations, the runbooks, the troubleshooting that happens in a day-to-day scenario, and we created a framework. So for example, let's say you push a config onto the router to configure a QoS policy. How can you guarantee that the same quality is currently available on that network? You have to, of course, issue a bunch of show commands, and you look at the output, and then you take some corrective action. You push more commands to the device, right? So this sort of activity, we are bringing automation to it. So the Atom itself will go provision config, checks the statistics using analytics, and if it detects any deviation, it goes and refines its policy and pushes the config back onto the device. That's the concept we are going towards. It's true, it's on the way to the intent-based networking, but I like to think this is something which you can use today with your existing brownfield deployments, Ethan. So I want to highlight that, Atom has been in production in large customers for a long time. We have we have been in business for more than 8 years, and large enterprises, large service providers have deployed Atom. I will go into a couple of case studies later as well. We have automated 45 different vendor equipment across multiple domains, including data center networks, branch networks, campus, SD-WAN, MPLS backbone network, etc. So let's go into the various features of Atom. The first feature I would like to introduce is the low-code automation with workflow. We understand defining a policy can be daunting. So we introduced a graphical designer using which you can drag and drop various decision logic modules onto a canvas. It's almost similar to a Visio diagram. We have many out-of-the-box workflows, but we understand it cannot match exactly what you have in your enterprise. So this workflow can be customized. For example, you may say, okay, as part of executing this command, I want to open a ticket in the service now, and only when it's approved, I will go issue the command. So you can mimic such kind of behavior into our graphical design. So this is very powerful. You can have a simple policy such as pushing ACL rule to thousands of firewalls, or it could be a very complex policy like software image upgrades, which requires many pre-checks, post-checks, etc. And this workflow engine can also be triggered by the analytics module. So if the Atom detects some deviation happening on the network, it will automatically trigger a workflow. And that workflow, as I said, can execute either commands to the devices like CLI or netconf commands, or it can even call APIs, or if the device supports a Yang model, it will execute the Yang model as well.
Workflow engine, graphical user interface, low code. I think that's a big piece to focus on for a moment here. You're saying I don't have to be a programmer in order to automate, because what you are giving me is a graphical tool that I can build automation workflows with. Now, I know we're going to see this a little bit later on, but the big idea here is with the UI, I can create this workflow that's going to accomplish tasks for me on the network, configuration tasks, as the case may be, but it also will interact with other systems I have. Is that the point you're making?
Yes, that is correct. If you want us to get IP address from, let's say, Infoblox IPAM, if you want us to, read the syslog notifications for a particular string, all of those things is the ecosystem that we are providing as part of Atom. We have integrations with 45 different vendors. They are not just the networking up devices, but also ITSM tools like ServiceNow, IPAM like Infoblox, and you will see later that it's a very comprehensive list, Ethan.
And Kieran, my question is around your ability to interact with devices to pull configure information out of them or interact with them. It looks like I see a list across the bottom, Telnet, SSH, API, and so on. So these are the mechanisms you're using to either pull information or push information to these devices?
Yeah, that is correct, Drew. We are on the management plane. We are not in the data plane. So that means we can issue show commands. We can read SNMP statistics. We can subscribe to any other, API calls from these devices. So that's the low-code automation. This is where you define the policy. Now, once you define the policy and the Atom pushes the configuration to the devices, we need to ensure the policy stays intact. That's where the compliance feature comes in. See, Atom is constantly reconciling the policy with the device configuration. If someone goes and manually edits a configuration, Atom can detect it and say that device is now out of compliance. We also have service level compliance feature. For example, let's say you deleted a VIP, but you forgot to delete the ACL on the firewall rule. Atom can detect it and say, hey, this service is now out of compliance. And we can also automate some of the day-to-day tasks. For example, let's say you want to change the SNMP community string, you can do that. Or you want to query the infrastructure and say, show me all the devices where VLAN 500 is configured. Or you can say, do not allow any weak passwords on any of my vendor devices, whether it's a Cisco router, a Juniper firewall, or F5 load balancer. You can enforce password complexity across multi-vendor infrastructure. Like that, there are many use cases where our customers have taken advantage of this compliance feature.
And so does a customer have to essentially build or configure these policies into your system?
Yes, so we will show you in the demo as well. So the auto reconciliation feature comes by default. You don't have to configure anything. If someone manually changes, it will automatically detect it. But these kind of rules where you want weak password or no SNMP v2, those things you will have to configure in our system. But it's vendor neutral, so it is fairly easy to express the policy.
You have there on the bottom left 45 vendors. Now, I've seen some folks make the claim that, oh, we support all these vendors. And what they mean is they support all the different languages of iOS within the Cisco world. So it's kind of like, they're stretching it a little bit. How do you mean 45 plus vendors?
Yeah, so it is actually like Cisco is one vendor, and inside that vendor you could have iOS XR, Catalyst switches, or you can have API based like Firepower or ACI. We have integration with multiple platforms, but it is considered as one vendor, Cisco. So like that, we have 45 different vendors. If you are counting the platforms like iOS XR separately, we have 150 plus platforms.
You mentioned I can set a standard for how I want NTP to behave, and I don't have to be code specific. So you're abstracting like the command details away from me?
That is correct, Ethan. Once a device is onboarded into our system, a router looks the same, whether it's a Juniper router or a Cisco router or Fortinet firewall. It doesn't matter. All of the devices will look the same. So your policy will be at the abstract level.
Okay, so I'm really building policies and workflows, and I don't have to think too much about CLI stuff unless I want to.
Yeah, like I said earlier, the workflow is there, so you can actually issue CLI commands if you really want to as well. So we try to avoid that, but at the same time, we have the flexibility to issue commands to the devices as well.
And I just noticed it says multi-cloud there, and you've got GCP, AWS, Azure listed. What does that mean? This is network provisioning if I have workloads deployed in the cloud too?
Yeah, so for example, we can configure the backend connectivity between your on-prem VPN device and the VPN gateway in the AWS cloud, right? So we can help configure interconnectivity and the network plumbing between your data center and the public cloud. In future, short future, we can also automate the workloads inside the AWS, like configuring the load balancers. Let's say you get a Palo Alto virtual firewall in your AWS, we'll be able to maintain the life cycle of that firewall. So that way, you configure the firewall policy once, it will push to the Palo Alto firewall on-prem, but it will also push the policy to the Palo Alto firewall in the public cloud as well. I also want to highlight that Atom is built based on Kubernetes and Docker containers, so it can be deployed in public cloud as well. So you can have an instance of Atom deployed in AWS Cloud, Google Cloud, or Azure Cloud at this moment.
If I'm not running Kubernetes or Docker myself in my environment, do I have to be concerned about that?
No, so we have a packaged Kubernetes in the product. So with simple one click of an installation, first we will install the Kubernetes, then the Atom Docker will be installed inside that Kubernetes. So you don't really need to know what Kubernetes or how to install it, but I'm just highlighting that, as the trend towards multi-cloud is coming up, Atom is built with microservices from the ground up. So the third benefit, after we provision the service, we are constantly collecting the data from the infrastructure. It could be your traditional SNMP data or the modern streaming telemetry. And Atom can collect all this data. So it can be a SNMP collector, streaming telemetry collector. It can subscribe to syslog messages. But if you want us, we can also read through any existing syslog servers like the Splunk, for example. So it can be a NetFlow collector as well. And it consolidates all of this data and publishes them to Kafka topics. So if you have any external applications, they can read this summarized information, and everything is stored in a time series database. We support the open source Prometheus database, the Influx database, or if you have a specific time series database, we can work with that as well. And we package the Grafana as part of our product. So you can build various custom dashboards, reports. You can also create threshold-based email alerts, etc. So Atom has a really modern software stack when it comes to telemetry. We will share one case study where one of the financial services provider was able to achieve the full streaming telemetry in their network.
Okay, we got to park here for a minute for sure. So I get the software stack aspect of it, but let's take a step away from that. Now, you're talking about me being able to collect a whole lot of telemetry, kind of the umbrella term these days for collecting data from a lot of different resources, and bringing it all into Anuta ATOM and having it do things, basically all the normal things I would have like an NMS doing for me. Does this mean I could get rid of my existing NMS if I wanted?
Yeah, potentially. If let's say if you are using mainly SNMP and you don't have any specific vendor features that you are using, then yeah, that is the vision where Atom can replace some of those traditional monitoring.
So it will be an SNMP poller for me. It can go out and pull SNMP stats.
Yeah, that is correct. You can actually define which MIPS you want us to collect and how frequently, and then how long you want us to retain this data. You will see that in the demo as well.
Syslog data. So I can send my syslogs to Anuta ATOM, and it is, I mean, how sad, syslog is such a wide-ranging topic. There's so many different messages and message formats out there. How well can Atom parse out the various syslog I might send it?
So syslog, there is a bit of a gray area, as you mentioned, Ethan. So that's one of the area where we will need to write some decoders or regular expressions to parse the data so that we can map it to the right attribute so that we can do the post-processing, like alert generation on the syslog. But rest of the scenarios where there is telemetry or like SNMP trap, where there is schema or more of a model-driven approach, we don't need to do any heavy lifting there, but for syslog, there's a bit of work involved.
Okay. So it can be done. You can write parsers if I wanted something custom. That could happen. Yeah. And then flow data, also interesting. A lot of that's standardized, but you can get into some, like with IP fix records, strange metadata coming through. Is this another case of we could make it do, whatever we wanted it to do to parse out those flow records?
Yeah, it will be fairly similar approach. NetFlow and SFlow are the two things that we're still working on. So that is something that we will be able to dig in on some of our subsequent conversations. All
right, model-driven telemetry. I'm sorry I'm asking on all of these. It's just they're all actually really top of mind here for me. When we talk about Yang models and moving towards a standardized way that our data is presented and sent up, it can sit there and just listen to telemetry that's being streamed off of network devices. Atom can receive those streams and parse that info?
That is true. That is true, and there are a couple of mechanisms there. One is compact payloads, and other is more like a JSON sort of payload. But in this scenario, pretty much the data is so well described, backed by a schema. So we can consume the data, we can put that into our storage, and we can do some like post storage analytics, or we can do it real time by connecting to our Kafka directly. So yeah, it all is facilitated by that more modern declarative way of sending the streaming data from the device out to the collectors.
Moving up to the second row there, we've got microsecond granularity. And Praveen, you were just talking about being able to parse that data, that real-time telemetry that's coming in. Is that what we're getting at with microsecond granularity? Are we talking about just time stamping of events? What are we getting at?
So there are a couple of things there, Ethan. So one is how frequently the device is streaming the data. So that's more of frequency, or like it could be near real time, or maybe not close to near real time, right? So that is where the frequency comes in. And then other is the timestamp itself, as you're indicating. What is the timestamp used when we're putting the data into the data store? And depending on the underlying technology, it might be milliseconds, it might be microseconds. And that's where we have the flexibility to kind of honor the actual timestamp that the device is generating the data, so that we don't lose any precision of the data. So frequency and precision both are important for the telemetry.
Top there, we've got Grafana as a way I can display data. Do I have access to that Grafana? That is, I can build my own whatever custom data representations, whatever I am looking for.
Yeah, you will have an API, and apart from the API, you can also plug into the Kafka. And the Kafka itself could be the Kafka that we provide along with the product, or it can be the customer's own Kafka. And similarly, Grafana can be the one that's packaged with Atom, or it can be your own Grafana. So we'll provide API access with them.
And then I think this is my last question for this slide. Sorry, but alerting. So I assume that means I can hook from Atom. You probably have your own alerting, but I could also hook into whatever other systems I might be running and pass alerts into those other systems as well.
That's correct. So that's where you connect to the Kafka and then collect the data. You write your own post-processing application. You put the data back onto Kafka. You publish like an SNMP trap or some other mechanism like a netconf notification also will do. So since Atom already has the mechanism to consume different sorts of southbound protocols, so we can pretty much like integrate in multiple ways.
Now that we spoke about telemetry and how Atom is collecting all the data, it gives you a powerful framework, and we call this concept closed-loop automation. Let me explain with an example. You can define the baseline for your infrastructure. Let's say you don't expect more than a couple of flaps for every BGP neighbor. Now, Atom can look at all the sensors and the data coming from them. So for example, if it's flapping once every 1 hour, you can create an alert or a Slack notification. But if it's flapping excessively, like more than 4 times in every 10 minutes, you can have Atom execute a workflow or execute a playbook that shuts down the neighbor. Granted, we are not yet ready for such automatic remediation. So we integrate with ticketing systems like ServiceNow. So Atom will preview all the remediation steps, and only when the operator is happy, he can actually approve it, and then Atom will go push the configuration to the devices. So we can bring this automatic remediation into the current networks.
So this is an important point to make. It's not just configuration and state of network enforcement. You can also react to what is happening on the network and make a change to the network based on what, like you gave this example of a neighbor flap. Neighbor's flapping, I want to change what the state of the network is as a result.
Yeah, that is correct. So we have rules based, so you can have different levels of actions based on the different deviations happening on the same metric.
For those of us that are frightened at the thought of something automatically based on a set of rules causing a change in the network, is there a testing method or something for this? We can kind of see what would happen if we lit up the rules?
So typically, whatever we're doing in this would have gone through a proper DevOps process where we would have developed, we have tested, and then we would have deployed into production. And even in those scenarios, it really depends on the comfort level you have with your procedures or mobs that you have defined. And if at all there is any room where you want to make doubly sure, right? So what we can do is before we change we can apply the change, we can actually submit a trouble ticket into like in a favorite ITSM tool. Somebody can come in and see what is the action that we're going to take. And then we can go and apply the change. But in a data center environment, if at all we are really looking at a very dynamic remediation process, we could possibly do the change. And that's where your trust in the data comes into picture, as long as the data is real time and the mob is thoroughly tested. It just depends on the confidence you have on the data and then the rules you're doing. But we do have scenarios where, to really make sure admin or an operator is kept in the process, we can have an approval cycle.
And for this closed loop component of it, so after reviewed whatever changes have been proposed and then push the button, make the changes, does Anuta then go back and double check again to make sure, yes, these changes actually went through and the problem is fixed?
So that's where the workflow aspects comes in, Drew. So the fact that we have done a change, again, it's syntactically the device might have accepted the configuration, but it's a behavior as expected could itself be a step in the closed loop automation, because we're going to be observing some other kind of data now, possibly,
Okay.
to see that things are all okay. So that's what is going to help us to clear the state of something has been broken, we fixed it, and then we can go back and clear what is the condition that we have to check for. All of those can be can be part of the alert definition, and we can take care of that.
So now I'll quickly wrap up the presentation so we can spend more time on the demo. Here I mentioned 45 vendors, right? You can see the list here. We support all the leading vendors: switch, routers, firewalls, VPN devices, web proxies, load balancers, SDN controllers, even IP address managers, ServiceNow type of ITSM tools. And we have integrations with SDN controllers, SD-WAN controllers, and this list continues to grow. It's part of the base package itself, and if a particular vendor is missing, we can add support for it within few weeks. We are using the IETF YANG models, which is a fairly extensible standards, so any customers or partners can also modify these device packages. So let me quickly walk you through a couple of customer deployments where Atom has delivered the ROI. The first customer that I would like to talk about is NuStar. They are a global DNS provider, but they also have a service called Site Protect that provides cloud-based DDoS mitigation service. So when NuStar's enterprise customers are under DDoS attack, all their traffic is redirected to NuStar's cloud. So on demand, NuStar has to provision an end-to-end circuit. So they have to configure a Juniper router, an Arista switch, a Citrix NetScaler, an Arbor Peakflow, and they need to ensure enough bandwidth is dedicated for each of those DDoS victims. So they are constantly collecting the statistics from these devices to ensure the SLA for each of their tenants. So Atom is helping them automate the whole network provisioning and collection of various network operational data. The second case study is a financial services provider, and they are consolidating network data from multiple formats like the streaming telemetry, SNMP, syslogs, path computation engine, NetFlow records, etc. And they consolidate everything into a time series database, and using the Atom API, they can expose this network data to northbound applications for performance monitoring, latency optimization, capacity planning, as well as predictive analytics and closed loop automation. So Atom is helping consolidate all the network data and introduce a single source of truth for these kind of customers. So this concludes the presentation portion for today. So I will now hand over the meeting to Dilip.
So hello everyone, I'm Dilip Krishna. I'm part of the product marketing team within Anuta. So let's quickly get started. So here's the brief agenda for today. So we'll touch upon the resource management aspects of Atom, and then we will look at some of the network automation capabilities of Atom. In the compliance section, we'll look at how Atom delivers configuration consistency in your network, how Atom can become a single pane of glass for your network in the telemetry analytics section. And to wrap it up, we'll see a concept called closed loop automation, where you can see how Atom can provide you an automated service assurance. So let's get started.
To those of you in the audience, if you were distracted looking at something else, this is the time to really zoom in because a lot's about to happen in a hurry. Drew and I have seen this, so this is the time to tune in closely.
Sure. All right, so what you're seeing here is the Atom UI, and Atom is a very open framework. So whatever operations we are about to do using the Atom UI, you can do it using your OSS, BSS, or the ITSM tools that you have in your network. So the first thing that we do when we bring in Atom into your network is onboarding of the devices. So you can see a list of devices here. I have taken one example to explain this a little bit more detail. So here you can see the various information that we collect from your devices. You can see the heat maps, your health, device health, compliance status, and all that. And we also retrieve configurations from your device. Now we can act as your config archival platform. You can choose a couple of your configs and do a compare of the configurations, where you can do a config diff there, right? And using this configuration, we also map it to the device models that we have. Now, for example, these are all Yang models, Yang data models of this particular device. And you can see I've chosen a couple of entities here. For example, I'm looking at the VLANs in this case, and all that you see here are the different VLANs on this particular device that I chose. So now we have the devices onboarded, we have the configurations ready, right? So now what we do is we go ahead and build the topology of your infrastructure. So you can see here that the topology is built using the CDP and LLDP tables on your device. But we don't stop there. We actually go ahead and overlay a lot of details on top of the topology. Now, for example, you can see the device details that I've pinned here, right? And also the operational data and performance data here. Now, for example, if you want to monitor the bandwidth of this particular link, you can actually go ahead and configure your sensors or SNMP data here. And based on that, you can actually have your real-time data overlaid on top of this topology. So now we have your devices onboarded, configurations retrieved, your topology ready to go, right? Now, this brings us to our next topic, which is network automation. Now, in network automation, typically there are two use cases. So one is a stateless use case, and then we have the stateful use case. So let's get to the stateless use case first. So I have a small slide on how this works. So when I mean stateless use case, this is more of a task-oriented use case. So you generally come and do an activity and just forget about it. And one such task is software image management, which becomes a very complex and tedious process in many of the enterprises. Mainly because in every vendor has a different way of doing it. Every organization have their own method of procedures of doing it, right? And that includes a lot of pre-checks, obtaining approvals. Then you have a lot of post-checks to be done, and the upgrade activity itself. And just in case it fails, then you have to do all these activities all over again. So it can be a very complex process, right? So let me take one example to explain this a little bit more, as in how our Atom's workflow automation or low-code automation can become a very handy tool for operations. Here you can see one of the workflow that I've chosen. But one point that I do want to mention, as Kiran mentioned here, that it is not just restricted to software image upgrade or maintenance upgrade. You can have your simplest of use cases, which could be like a device provisioning, like a firewall provisioning, anything that can be your simplest use case, or it can become the most trustful, trustworthy troubleshooting guide. You can become your entire documentation for all your method of procedures that you have in your network. So this can become your really helping guide for your entire network operations. The one that I've chosen here is an example of software image upgrade, which we delivered for one of our customers. So let me just walk you through this particular flow. So you can see here that we have few boxes, which we can really drag and drop and create this workflow. And these boxes here are the pre-checks. So we have executing few of the show commands, right? And then as part of the action, if these are successful, we go and execute a particular action. Now that action here is like a call disk space check. Now this itself is a workflow. So what is happening is we have a main workflow into which a subroutine is being attached. So we have another workflow being attached to that. And let's say this particular workflow is successful, then we go ahead with a lot of tasks that have been created, a lot of system tasks that have been created, like cleaning up the unnecessary files, or it could be uploading the new package, contacting the image server. So you can do all that. And finally, we get to a stage where we have to reboot the router. Basically, you have to reactivate your new package, right? So at this point, we have to reboot the router, and we have integrated a user approval into this. The admin can actually log into Atom and give an approval, or the approvals can come from a ServiceNow, it can come from a Slack note, from a Slack, it can come from any of them. And once that happens, we go ahead and reboot the device. And now, from a notification, from an SNMP notification or trap notification, we're going to find out that the device has come up. And then we can execute few post checks in this case. And we understand that sometimes the upgrade wouldn't go well due to whatever reasons it may be. And we have also factored in that into this workflow, where you can see that we have put in a section which can help you to revert back to your last best known image also. So what we are giving you is a framework where you can have pre-checks, post-checks, approvals, and the activity itself, right? A very flexible framework. And all this can just be dragged and dropped, and you can create your own workflows to get there.
And all of these boxes on this workflow look familiar to people who have done flow charting ever in the past. And this represents things that are actually happening. This is a design tool that results in an actual workflow, yeah?
That's true, that's true, that's true. So this is about the stateless use cases. So now let's look at the stateful kind of use cases, right? This is a case where you want to create a service across your network, and then you probably have to update the service, update the ACL rules, or create more routes. It's probably you have to maintain the entire life cycle of that service. So those are the ideal candidates for the service modeling that Atom services. So let me take one example again to walk you through this. So the first one here, what I have is an application delivery use case. So here you can see that I have a load balancer, a firewall, and an Infoblox IPAM device. And ideally, if you want to provision a service across these, you might have to run across multiple teams to get this provision, and there might be delays in provisioning itself, right? So you want a single form where I can populate the entire parameters for firewall, load balancer, Infoblox, and then with a single click, an entire provisioning should be done. So that is what we can provide you with, and I've already executed this in the interest of time, right? So what you can see here is the set of parameters. So if you can see here, we have the load balancer VIP pool. You can see the firewall parameters here, and the IPAM also, IPAM A records, which is because IPAM is acting as a DNS in this case. So what happens is the Atom actually converts all these into different commands. Now it could be that the device is accessible over an API or a netconf, or it could be a CLI command itself, right? So you can see we are contacting the IPAM device using APIs, and some of the Juniper commands here this is an SRX device that I have, so some of the Juniper commands are also automated. So irrespective of what transport type we use to access that particular device, we can provision any of those, and we can do this across 45 different vendors.
The point being, I don't have to know all of that stuff or worry about those. I'm building a model. Atom is abstracting away the details of how the devices are configured to meet that model away, and I can see all the code if I want to. You just showed it all to me, but I don't have to know or care.
Yes, all abstracted. That's true. Yeah. All right, so that brings us to the next topic, which is basically compliance, right? So we'll look at how the Atom works on that front. So so we already discussed how Atom retrieves the configuration from the devices and does the service provisioning. But what Atom also does is to look for any of the out-of-band changes. Now it is very much possible that a network admin goes and changes a configuration as part of a troubleshooting activity, right? So we can quickly detect that configuration difference. So for example, in this case, the VRF is a missing piece in the config, and it also gives the configuration that needs to be reconciled. Now this can be automated, of course, but we also give the power to the admin to basically override the configuration. So for example, if the change on the device was not legitimate, we can ask Atom to override the golden or the base config back into the device. Or let's say the change was actually legitimate, then we can ask Atom to take that configuration and write it back into its database, so that we regularize the configuration across your network. And we do not just do it for the devices alone. That can be extended to the services also. So the application delivery that we just saw in the previous example, the same can be can be an ideal candidate for any kind of the service reconciliation as well. So that is the compliance aspect of Atom. The next interesting topic that I have is telemetry and analytics, and we can see how Atom can become your single pane of glass. So here you can see that now we can be your collector for SNMP, streaming telemetry, SNMP traps, and syslogs. I'll take SNMP and telemetry for today's demo. So you can see here that I have a SNMP collection profile ready to go. And what I can do is I can choose from the number of out-of-the-box SNMP MIBs that I already have here. If you do not find some of the SNMP MIBs in Atom, you can actually download it from the internet and upload it to our Atom database, and then it should be available here. So you can choose from the numerous SNMP MIBs that you can see here, and then you can put in a polling frequency as well. And once you have the collection profile ready, you can just push it to a single device or a group of devices, or it could be a resource pool. For example, a location, right? Your data center itself can be a resource pool, and you can just push all this data in there. And once configured, all the performance-based SNMP data that comes back is stored into our time series database, which can be a Prometheus or InfluxDB. Now, the same is applied to these telemetry aspects also. So as you might know that the streaming telemetry is very hot these days, and Cisco and Juniper, the new generation Cisco and Juniper devices support a lot of them support this particular technology. So you can see that Atom supports that. And you can choose the platform here. We choose the different transport types. It could be your Google Protocol Buffer, the gRPC or the TCP, the dial modes, the payload encoding, right? And then you get to choose from the numerous sensors that are listed here. So let's say the device supports many sensors. You can choose any granular kind of sensors that you want to any depth that is possible. Then you can choose a frequency at which you want to collect that, and also the data retention. So you have huge data coming in, so you may want to say that, okay, I want to retain this data for a year or a few months or days, right? So, and you can also filter the data. And again, once you have this profile ready, you can push it to, again, a group of devices or device that supports the streaming telemetry. Now, once this happens, we subscribe to those sensors, provision the devices for those particular sensors, and all the data that comes in, that also includes the SNMP data that I discussed, everything is going to be exposed as a data source into your Grafana dashboard. So Grafana, like we discussed earlier, is a very flexible and customizable visualization tool. So you can basically customize it to your needs. So you can, for example, I'm looking at a particular interface here. This could be bubbled up to a device or even a network level. And if you have a Grafana already in your network, you can actually use that for your visualization purpose as well. So now we have done the telemetry and the analytics. So we have a lot of data coming in. And as Kiran mentioned, we use this to trigger a framework which is called as closed loop automation. So I'll quickly take a couple of examples to make this a little bit more clear. So I'm taking an example for CPU utilization notification. So for example, you can see that I have a framework where I can define conditions, and I can choose any of the functions that are available here. I can mention a particular sensor that I want to monitor. Now, this could be a single sensor, or you can just keep on adding and mix. You can just mix and match any number of sensors here. You probably monitor your CPU as well as memory. And then you can set a threshold here. So you can say that, okay, I don't expect it to go beyond 70%. If it goes beyond 70% for a period of 5 minutes, then I can set a severity to it, and also take a action. Now, this action could be to send an email to one of the network admins or a mailer group, or it could be a Slack notification, or we can even send raise an alarm within different categories that are available here. So this is one example. So this is about notifications. Now you can take this to a next level of auto remediation also. So I'm taking another example, which is for BGP neighbor flaps. So here we give you an option to basically express your conditions in multiple ways. The first one could be the one that I showed you earlier. And here you can basically query our database. It could be the Prometheus or the InfluxDB that we support. You can choose one of them. I can say that, okay, show me if the connection state changes more than 5 times, then I need to set an action here. So, right, so that action again could be a notifications that we discussed, or it could be a remediation action also. So it's like shutting on the neighbor, shutting on the interface, or it could also be to invoke a workflow. So we know that all the remediation actions are not straightforward. So you can actually go ahead and write a workflow to basically address your remediation actions. So a very simple example, let's say it might not be the right one here, but at least if you want to, let's say, as part of the CLA, you want to create a L3 service, you could do that also. So you can just trigger this workflow using the CLA.
You're saying with this closed loop automation, essentially you can, like using the workflow tool, you can say, I'm building workflow to, in case of this condition, execute these commands, and then just click a button, it's going to happen.
That's true. So based on the CLA, we can the action can be to trigger a workflow itself, and in that case, it could be any of them. It could be an approval process itself, for example, to take that action. It could be an approval, like Praveen mentioned. You can actually go ahead and take an approval through the service now, and that any kind of workflows can be integrated into the closed loop automation.
Got it. Okay, thank you.
Thank you, Dilip. So I want to conclude by saying that Atom is a integrated solution that supports all the way from onboarding the devices, provisioning, analytics, and as you saw, closed loop automation, which simplifies the day-to-day operations of network operators. And it uses the modern architecture. It scales to thousands of devices, and it's proven in large enterprises and large service providers. So we welcome you to check out the additional resources. We have set up a website called anutanetworks.com/packet-pushers. So the first 30 people who register will get the Anuta t-shirt. You can also check out the full demo that Dilip showed today, and also the additional data sheet as well as case studies. Thanks a lot for giving us this opportunity, and we look forward to continuing this conversation.